Hi, it's time for another math easy solution. Today we're going to discuss further into improper integrals and now go over example 1 of the example series and cover this example, which states determine whether the integral, this one from 1 to infinity of 1 over x dx is convergent or divergent. So recall from my earlier video that I went over my last one on type 1 integrals, which is about infinite intervals. Basically, we could write this function as, or this integral as 1 infinity 1 over x dx. We could write this as a limit. So limit as, let's say, t approaches infinity of, now instead of writing it 1 to infinity, we go 1 to t of 1 over x dx. So instead we're writing this infinite interval as a limit. So this equals to the integral of 1 over x. That's just ln absolute value of x. You could see my earlier video in the link below on the proof of that. So this equals to limit t approaches infinity, and the integral is just going to be ln, this is going to be x. And this is from 1 to t, so we're evaluating it from there. So this equals to limit t approaches infinity, and now when we put these inside, we get ln of t minus ln of 1. And since both t and 1 are positive, we can remove these absolute value signs. Anyway, so now this ln of 1, if we recall our logarithmic properties, this is just equal to 0. So that goes to 0. We are equal to now limit as t approaches infinity of ln of t. And when you plug in t, as it goes to infinity, basically we're going to have a ln infinity, and ln is always increasing. This is going to be, well, just infinity. So since it's infinity, this means that, well, the limit does not exist. D and E, I'll just write that. So the limit does not exist, and here, since the limit does not exist as a finite number, but it's set as an infinite number, this integral is considered divergent. So it diverges away from a finite number. So that's one way you could view that. So now, yeah, let's compare the result of this example with the example given in my earlier video on type 1 improper integrals. And that one I went over, I basically went over integral from 1 to infinity of 1 over x squared dx, and then we basically found out that this converges into a finite number. So this converges, and then compared to basically the one we have right now, 1 to infinity of 1 over x dx, this diverges. Yeah, and now if you were to graph these functions out and compare them side by side, as you can see, this function look similar, but as you can see in this one, where it converges this area underneath and to the right of 1, it gets closer and closer to the 0 really quick. So this one results in a finite area. And then this one right here, it doesn't actually approach 0 fast enough to be finite, so this area is infinite area. So this is an infinite area. So this is one way of looking at these two functions. Yeah, and basically geometrically, as I just drew it out, this this says that although the curves y equals 1 over x squared and 1 over x look very similar for x is greater than 0, the region under this one right here, this y equals 1 over x squared, to the right of x equals 1 area, it has finite area, where the other one has infinite area. So I just stated. And again, as I stated, basically note that both these curves approach 0 as x goes to infinity, but this one right here approaches 0 faster than the curve for 1 over x, and the values of 1 over x don't decrease fast enough for the integral to have a finite value. So it keeps going on and on. This one here, what we're really doing is increasing, well, let's say the furthest decimal place is getting higher and higher, but it doesn't increase fast enough so that any meaningful area gets increased, and this is all we're doing is approaching exactly area of 1, as I showed in my earlier video. Anyways, that's all for today. Hopefully you learned from this quick example video, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.